is a short version of a very long 20 minutes one I uploaded in my YouTube channel. It's about continuously compounded interest as well as continuous investment. Interest works as follows. We have an amount of money called principal sometimes. Okay, for example, equals to 1,000. And this is the money invested, and we have a rate of investment which is annually expressed. So this, for example, R equals 10%. In mathematics we write like 0.1. So you invest something which is 1,000. After 1 year you get 1,000 plus 10% of 1,000. That's equals to 1,000 plus 0.1 times 1,000, which is 1,000 plus 100. So mathematically this is expressed as K plus the rate, so K is 1,000 plus the rate 10% of K, or K times 1 plus R. If you do the same thing for 2 years, you have two options. What is simple interest, where you just withdraw your 100 from the bank. So you have 1,000. After 1 year you get 1,100, and you invest only 1,000 of them, and you get 1,100, and at the end you have 200 as interest. Or compounded. Compounded interest means you have 1,000, and then you get 1,100, and you invest this, so you get 1,100 plus 10% of 1,100. So in the compounded interest of an amount K, annually rate R, for 3 years we have K times 1 plus R raised to the T power. What about if the interest is not paid annually, but it pays, for example, twice a year? So suppose your interest rate R is paid twice a year. In that case, what you have is that at the end of the first semester you get 1 plus R over 2 times K, and at the end of the second semester 1 plus R over 2. So at the end of 1 year you get K times 1 plus R over 2 squared for 1 year. And for T years you get K times 1 plus R over 2 to the 2T for T years. You can assume the interest is paid every 4 months, every 3 months, every month. You can assume the interest is paid continuously. Interest paid continuously. So that means you have 1 plus R divided by K, the number of periods, and that happens K times when K goes to infinity. So what you have is K times 1 plus R over K to the K goes to K e to the R for 1 year, and K times e to the RT for T years. And that's the continuous interest. Let me write it here. Continuously compounded interest of an amount K with a rate, annual rate, for T years gives you an amount of K e to the RT. Now that we have not only the interest is paid continuously, but the investment is done continuously. Like you go out of the bank and come back to invest, and come back to invest, and come back. So suppose you have T years, a rate of R, which is an annual rate as usual. So here you have your time. So whatever amount you invest here is invested T years continuously. So this amount, if this amount is f of 0, this amount will produce you something like f of 0 e to the RT. Now invest a little bit of time later. Say time here is, I don't know what, some certain amount T1, and you invest an amount of f of t1. So this amount is here invested for the time this amount is invested is t minus t1. So the money produced is the amount invested times e to the r t minus t1, the small t1 here. Let me make it clear. Another amount of time here, t2. At time t2, you will invest an amount which we'll write by f of t2. So how long is invested will be all the time as at the very beginning. So time of this investment is t minus t2, and by the formula of interest paid continuously, we get this is f of t2 e to the r t minus t2. Now you have to do this continuously, and when you have infinite sums in mathematics, reminds you or should remind you of integrals. So suppose you have an f of t is the investment at time t done continuously. Oh, sorry, time t got very dirty here. At time t for an amount of years, capital T, where you have an annual rate. Let me write annual rate of R. So then what is called the money you get at the end you have at the end of your period of T years, you will get what is known as the future value, because it's the value of your money in the future, FV, which is equals the integral from 0 to t of your investment and whatever each of the investment is giving you. Remember, if you invest at time t, right here at time t, the time this money is invested is capital T minus t, hence the formula. You can also take e to the rt as a common factor out of the integral, and that will be 0 to t f of t e to the minus r small t dt. Finish the video, I'll explain what is the present value. So you have, as before, you have an income stream, an investment for t years at a rate of r. And at the end of this, you get what is called the future value. Now the question is, how much is worth that value now? Or in other question, how much you need, how much money you need to put in the bank now, not little by little, by now, to get the future value at the end. Well, that formula we have before, if you invest A for T years at a rate of R, continuously compounded, what you get is A times e to the RT. So you want to know how much aid I need, so in the future, that's equal to my future value, which is e to the RT, times the integral from 0 to t of your investment e to the minus RT dt. So canceling the exponentials, you get that the present value, which is a, denoted as present value, is the integral from 0 to t of your investment stream times the exponential. Alright, the future value is the money you get from a continuously compounded interest for a period of time t with a continuous investment. For example, you have a business and you are making money and you are investing it. The present value is the money you should put, money you have to invest now to get some future value of something. And the formulas are, for the future value, you have e to the RT, integral from 0 to t, f, one second, erase this, okay, f of t, e to the minus r small t dt. And the present value is the same formula, except it's missing the factor outside, so it's only the integral part. I will put some examples later.